Welcome to the Unit 1 Assessment Review. I'm going to go through each question and solve them for you to review to prepare for the test. The first question reads, which Venn diagram correctly represents the relationship between rational numbers and irrational numbers? So I want to make note that I'm looking for the Venn diagram that is correct. That's important because sometimes it asks us to find the one that is incorrect or not true, so making sure that we're finding the one that is correct. And that's the relationship between rational and irrational numbers. So when I look at A, we have rational and irrational numbers separate because rational numbers and irrational numbers have no numbers in common. B, where we have rational numbers and irrational numbers slightly mixed because some irrational numbers are also rational numbers. On C, we have all of rational numbers inside of irrational numbers because all rational numbers are irrational numbers. In D, we have all irrational numbers inside of rational numbers because all irrational numbers are also rational numbers. Well, I know that the correct answer is A because I know that rational numbers and irrational numbers have no numbers in common. And so just to refresh our memory, when we think about the Venn diagram, in the innermost circle, we have natural numbers. Those are the counting numbers. So 1, 2, 3, and so on. Following that, we have our whole numbers. Whole numbers includes all of the natural numbers, which is why the natural numbers is inside of whole numbers. And it also includes the number 0. So 0, 1, 2, 3, and so on. Following the whole numbers, we then have integers. Again, integers includes all of the natural numbers, all of the whole numbers, and their opposites. So what's meant by the opposites are the negative numbers. So while we have 1, 2, 3, and then we have the 0 from the whole numbers, we also have negative 1, negative 2, negative 3, and so on. And after integers, we then have rational numbers because rational numbers includes all of the natural, all of the whole, and all of the integer numbers because they can all be written as a fraction. So remember, rational numbers are numbers that can be written as a fraction. They are repeating decimals and terminating decimals. So decimals where the numbers repeat in a pattern or if the numbers come to a stop. And then on the side, we have irrational numbers by themselves because irrational numbers cannot be written as a fraction. They are non-terminating decimals and non-repeating decimals, meaning that they go on and on and on forever. And all of these are considered real numbers, which is why we see in each of our answer options both types of numbers are inside the real numbers because, again, all numbers are real numbers. Moving on to question 2. Question 2 reads, the points on the number line represents the values of 4 different numbers. Which point best represents the value of square root 3? So when I think about the square root of 3, I know that this is a non-perfect square, meaning that there is not a whole number that you can multiply by itself that will give you 3. So for instance, 1 times 1 will give you 1, 2 times 2 will give you 4. It skipped the number 3, making this a non-perfect square. So what you would do is take a number line, or you could use the one that you have here. I'm just going to draw the extra one down here. And I'm going to think about the 2 perfect squares that the square root of 3 would fall between. And again, that would be the square root of 1 and the square root of 4. And the square root of 1 is 1, and the square root of 4 is 2. Meaning that the square root of 3 is going to be somewhere between 1 and 2. Well, between 1 and 2, but not more than 2, because 2 is the square root of 4. So when we estimate these non-perfect squares, you want to think about distance. I know that there's only 2 numbers between 1 and 4, and that's 2 and 3. You want to make sure that they're evenly distributed. So we would say that this is the square root of 2, and this is the square root of 3. And we would say about here is the halfway mark. So when I look on our diagram here, obviously D is out. It's way past the 2, and A as well. So again, we just found down here that the square root of 3 is past the halfway mark. And when I look here, C is past the halfway mark. So C would be the correct value for the square root of 3. All right, next we have a scientific notation question. It reads, at its core, the sun can reach temperatures as high as 27 million degrees Fahrenheit, or 27 million degrees Fahrenheit. How is this temperature written in scientific notation? So I'm just going to write that number just so that we can see it a little more clear. I know the text is pretty small. So whenever you are dealing with scientific notation, you want to first ask yourself, am I dealing with a really big number, or am I dealing with a really small number? And when we look at 27 million, obviously that's a really big number. So anytime you are dealing with a really big number, that tells you that your exponent is going to be positive. So if your number is big, your exponent should be positive. If your number is small, then your exponent should be negative. So knowing that, I can already do process of elimination and get rid of B and D, because both of those, sorry for the focus, trying to get that right. Okay, so again, as I was saying, if your number is really big, such as 27 million, your exponent should be positive, and if it's small, meaning a decimal, then your exponent should be negative. So because we're dealing with the big number, we're going to get rid of -6 and -7, because again, we're dealing with a big number. Now that we have eliminated some of our options, we should always remember that we always multiply by 10. Always, always, always multiply by 10 when you're dealing with scientific notation. So when we determine the number that we're going to multiply by 10, you want to get a number that is between 1 and 10. 1 and 10. So right now, we're looking at the number 27. Well, 27 is not between 1 and 10. So I'm going to move my decimal until I have a number that falls between 1 and 10. So now here, if I place the decimal here, I have 2.7. Well, 2.7 falls between 1 and 10. So 2.7 will be the number that we multiply by 10 to the power of the number of times you move the decimal. So we move the decimal 1, 2, 3, 4, 5, 6, 7 times. So our exponent would be 7. So 2.7 times 10 to the 7th power is the correct answer, which is C. Moving on to number 4, it asks us which inequality is true. Now, whenever we are dealing with comparing numbers or ordering numbers, the first step we should always do is convert all of the numbers to decimals. The reason we convert all of the numbers to decimals is because it's easiest to compare decimals, because we deal with decimals quite frequently, like dealing with money, right? So again, decimals is just the easiest to work with. You also want to make note of the signs. So we have this sign here, which stands for less than. And this here is greater than. So again, when I look at A, it's not easy for me to compare these because I have a fraction and a non-perfect square. So what I'm going to do is convert both of these numbers into a decimal. So to convert a fraction to a decimal, you divide the numerator by the denominator. So I'm going to do 10 divided by 3. And I ask myself, how many times does 3 go into 10? It goes 3 times. So 3 times 3 gives us 9. So we will take away 9 and we're left with 1. Well, 3 does not go into 1, so we would add a decimal and a 0 and bring that down. And ask ourselves again, how many times does 3 fit into 10? Again, that is 3. Now, when we do 3 times 3, we get 9. We're left with 1 again. We can see that we're going to continue with the same pattern because this is a repeated decimal. So we're just going to keep getting 3 over and over and over again. So we would just stop there and put this bar over it, letting us know that that number is continuing on and on and on. So I'm just going to write here that this 10/3 is equivalent to 3 3/10 repeated. Now that I have this number in decimal form, I'm going to go ahead and do my square root of 10. And again, the square root of 10 is a non-perfect square. So I'm going to have to estimate using 2 perfect squares. And so I know the 2 perfect squares that the square root of 10 would fall between is the square root of 9 and the square root of 16. So the square root of 9 is 3 and the square root of 16 is 4. So I know that the square root of 10 is going to fall somewhere between 3 and 4. Now, if I'm dealing with the square root of 10 and the square root of 9 is here, then I know that it's going to be really, really close to the square root of 9 if the square root of 16 is way over here. So if I determine that this is the square root of 10, I would estimate that this is about 3.2. So 3.2. Again, not the exact number, it's an estimate, but you want your estimate to be close. So I ask myself, is 3 3/10 less than 3 2/10? Well, no. And again, if it's easier for you to think of this in terms of money, you can always add that 0. So is $3.30 less than $3.20? No, $3.30 is more than $3.20, therefore making that incorrect. Moving on to our next option, we have -1/8 is less than -1/3. So again, converting them both to decimals, because even when you have the same form as in these fractions, it's still not simple to do because they have 2 different denominators. So again, the easiest thing is to convert them to decimals. So I'm going to ignore the negative sign and just add that back on at the end. So 1 divided by 8, excuse me. Well, 8 does not go into 1, so we're going to add a decimal in the 0. Wow. And 8 goes into 10 one time. So we take away 8 because 8 times 1 is 8. And we're left with 2. 8 does not go into 2, so we add a 0 and bring it down. 8 goes into 20 2 times. 8 times 2 is 16, leaving us with 4. 8 does not fit into 4, so we are going to add another 0, making that 40. And 8 goes into 45 times. 8 times 5 gives us 40, and we are now left with 0. So negative 1/8 is equivalent to negative 0.125. And if you want to round that, that's fine. Now we can go ahead and do negative 1/3. So 1 divided by 3. 3 does not fit into 1, so we will add our decimal and a 0. 3 goes into 10 3 times. 3 times 3 is 9, so we take away 9. We're left with 1. 3 does not fit into 1, so we add that 0, bring it down. 3 goes into 10 3 times. Take away 9 because 3 times 3 is 9, and we're left with 1. We are running into the same repeated situation that we saw over here. So this lets us know that 3 will just keep repeating, and so we'll just write that bar over it. So negative 1/3 is equivalent to negative 33/100. So when I ask myself, is negative 0.125 less than negative 33? That is false, because negative 0.125 is greater than negative 0.33. And I know we get a little confused with negative numbers, but just remember, the bigger the negative number appears, the smaller it actually is. So it's like saying, would you rather owe someone 33 cents or would you rather owe someone 12 cents? Well, I would rather owe someone 12 cents because I would have to give them less of my money, and therefore making that a greater number. Looking at our C option, we have a percentage and a whole number. So we know that there's always this imaginary decimal at the end of a number. And when we convert a percentage into a decimal, we just move that the decimal 2 units to the left. So this would give us 1.50. Well, $1.50 is not greater than 2, making that incorrect. And lastly, D. Both of these are already in decimal form, so we don't need to convert them. Again, I'm just going to add that 0 because I like to look at decimals as money. And so, would I rather owe someone 7 cents or would I rather owe someone 70 cents? Well, I would rather owe someone 7 cents because, again, I would have to give them less money, meaning that this is a greater number, which is what this sign here indicates. So D is the correct answer. And last but not least, we have number 5. And number 5 reads, which list shows the numbers in order from least to greatest? So the first thing you want to do is make note of the direction that it's telling you to order the numbers from least to greatest. So from smallest number to the biggest number. Again, just like with comparing numbers, after you make note of the direction, you want to convert all of those numbers to decimals. Okay. So I'm just gonna, and when we look at all of the answer options, they all include the same numbers. So you don't have to convert each answer option. You just have to do each number that one time. So I'm just gonna write them all over here on this side. We have -4/3. We have -43/100, the square root of 3, and 5/2. Now this one here is already in decimal form, so we don't need to convert that. So I'm going to go ahead and start here. -4/3, I have a fraction, so to convert this to a decimal, I have to divide. So 4 divided by 3. 3 goes into 4 one time. 3 times 1 is 3, leaving us with 1. 3 does not go into 1, so we add our decimal and a 0. Bring that down. 3 goes into 10 3 times, taking away 9, and we are left with 1. And at this point, we should have recognized that if we ended up with 1, we're going to add a 0. We're going to keep getting the same number over and over again. So we're going to put that is a repeating decimal. So -4/3 is equivalent to 1 33/100 repeating. And again, this one's already in decimal form, so we can leave that one as is. Excuse me. We have this non-perfect square. Again, whenever you have a non-perfect square, you want to use the two perfect squares that it will fall between. If I'm looking at the square root of 3, I know that will fall between the square root of 1 and the square root of 4, where the square root of 1 is 1 and the square root of 4 is 2. So again, we want to think about distance, making sure that it's, equal in distance. So if this is the square root of 2, then this is the square root of 3. So I know that it's more than 1.5, but it's less than 2. And so I would estimate this to be about 1.7. And now again, as I told you guys when we were working on this in class, some of our answers might vary slightly. Someone might say 1.6, someone might say 1.8, and that's fine as long as it's relatively close to each other. And last but not least, 5/2. So again, I'm going to divide the numerator by the denominator, and 2 goes into 5 2 times. 2 times 2 is 4. We're left with 1. 2 does not go into 1, so we're going to add that decimal, bring down the 0. 2 goes into 10 5 times. 2 times 5 is 10. And we are left with 0. So this is equivalent to 2.5. Now, again, I like to think of decimals as money. So I'm just going to add those zeros afterwards. They're just placeholders. So I forgot the negative sign there. Okay, so when I think about putting these numbers in order from smallest to biggest or from least to greatest, the number that I don't like the most, if I was thinking in terms of money, I would not want to have negative $1.33. So that lets me know that -4/3 is our smallest number. So when I look at our answer options, B does not start with -4/3, so I can eliminate that, along with D. Moving on, after this one here, again, the last 3 numbers, there's only one additional decimal, letting us know that that number is the smallest of the 3 remaining numbers, which is -43/100, and they both have -43/100, so we have to look at our next one. Then I asked myself, would I rather have $1.70 or $2? Let me take that back. Which one is the least amount of $1.70 or $2.50? Well, $1.70 is less than $2.50, meaning that the square root of 3 is smaller than 5/2. So when I look at our answer options, A has the square root of 3 next, and then the greatest number, 5/2, last, making A to be true. And that is it, guys. Good luck on Tuesday.